I want to now just talk to you a little bit about creation or evolution, looking at the evidence. And what we're looking at in this talk is the fossils. Now, I'm not an expert on geology. I don't claim to be an expert. I'm just going to take a very much a layman's position. I love picking up fossils. I love looking at them. And what I find is that when I look at them, just as a person who knows that a little bit about the way things can be buried from just experience and the way that we look at the world, we can actually see an awful lot which doesn't require a degree in geology to actually come to conclusions which are very interesting and consistent with the Bible. Clearly, there are issues when we consider geology. We're looking at rock layers, and we're looking at fossils, some of which I have here. And people think that immediately these days you've got to have millions of years in order to understand them. But what I want to show you is that the argument isn't really science on the one hand and Bible-believing Christians on the other who haven't got an understanding at all about science. No, it's actually people doing science. We have actually expert geologists in the Answers in Genesis group, and there are a number of DVDs done by professional geologists such as Andrew Snelling, Paul Garner and others, and they've come to straightforward conclusions that there is evidence of catastrophe. On the other hand, you have secularists who look at the same evidence and tell us that this is millions of years. The argument then isn't actually about science versus the Bible. The argument is about worldviews, which Stuart mentioned earlier. There are, of course, important questions. Is Genesis reliable? Is man just a different variety of some ape-like creature? Does it matter? Yes, it does matter, because if this isn't true, then we, of course, are in the position, like I was saying at the beginning when I introduced the whole day, we're in the position of not having a Bible which is reliable. So what I'm going to do in this talk is take a very straightforward look at creatures we have today, like the giraffe, and the fossils. I won't necessarily go through them all, but I'm just going to make a point to begin with, which is we've got these creatures we have today, and there are many examples where we can find those same creatures in the fossil record. So it really does therefore suggest at that point that there's an awful lot in the fossils which doesn't speak of evolution. Now, I need to make another point before I go into this, and that's this. I'm going to, for the first part of the talk, assume the millions of years, even though I disagree with them, right? So it's a well-known way of arguing. Instead of simply saying, straight off, the millions of years are wrong, I'm going to say, even if you were to take the millions of years and to take, a gradual development idea, it doesn't work, because you don't actually find the very things which the evolutionist says are there. Then I'm going to come in the second part of the talk to actually show you that the millions of years are not right anyway. All the evidence is showing catastrophe. So you understand the logic in which I'm speaking. I'll be fairly quick with these examples of creatures we have today and creatures in the rocks, and I won't necessarily choose to do them all. But the giraffe has special muscles in its neck to avoid a brain hemorrhage. It also has very special joints in the bone structure of the neck, such that it can swivel each joint of the order of 270 degrees. So those incredible joints in the neck, the ball and socket joints, which no other creature has, we certainly don't have them. we can bend our neck, but we can't bend each individual joint that the giraffe can do. Those are wonderful design features which we could speak on. But my point is that actually when you look at the fossils, they are recognizable, believe it or not, as giraffes. So we have, therefore, fossils in the geological column. Supposedly, the evolutionists will talk about here millions of years. I don't accept that at all. This is the labeling of the rocks, which I don't really have a big problem with, because we do find different types of rock all over the world. We find Cretaceous limestone. We have, in that same layer, sets of layers, we have chalk and other types of rock. And William Smith was the person who actually devised the beginnings of what became the geological column. This, well, even that isn't really strictly true, because you can find a huge number of mammals displaced from the region where the evolutionists would say that they should be. We do actually find mammals even down here. There have been mammals, the odd fossils found even down in the Jurassic. There was one just recently which was a mouse-like creature which was found down here. So, but just for the sake of argument, I'll just take that progression, which evolutionists say that life began in the sea, and then eventually you got fish, and then you got reptiles, and then some of the reptiles, they say, became birds, and then other reptiles became mammals, and then some mammals decided to go back in the water, land mammals, and become creatures like dolphins, and then, hey presto, eventually you get man. You know the evolutionary account. But just taking that view, I don't accept the millions of years, but just for the sake of the argument, I'm just taking that view for the moment and saying giraffes are exactly the same in the fossil record as today. The only difference possibly is in the size of the skull. Let's have a look at another one, which is a feather. Now, a feather has an amazing structure, which is only visible under the microscope, of a sliding barbule structure, where one barbule going one way has hooks on, a barbule going in the other direction from the barb has ridges on, which enables each adjacent barb to be connected together, because in between the barbs there is this amazing... Oh, we've lost... Oh dear. We're back to the same problem. Is there anyone who can help? We have a problem. Is there anything that can be done, or are we without it? Okay. Yes, I can indeed. What I'll do is I'll just dig out my feather, which is down here. I wasn't anticipating that, of course. I'll just dig out my feather. Yeah, I will in a moment. Let me just deal with the feather. So a feather, while we wait, is an amazing structure. And I was just talking about the way that each individual barb hangs together with little barbules connecting each barb together. But what I was going to go on to show you, and I'll just describe it, is that in amber, which is hardened resin from trees, what do you find? Well, you find insects sometimes, you'll find other creatures trapped in them, but occasionally you find feathers in the amber. And guess what? The feather is identical to a modern feather. And yet the amber is supposedly meant to be 25 million years old. Amazingly, looking at the Archaeopteryx, which supposedly is meant to be 125 million years old, but here you can see an Archaeopteryx, part of an Archaeopteryx fossil, and it's a feather. It clearly had fully developed feathers. And what's more, I can tell that it is a fully developed feather because it's no sort of ancestral feather. It is very asymmetric. It's probably a secondary feather on the Archaeopteryx. Those who know about flight, and I do know a little bit about that area, know that you have primary, secondary, and tertiary feathers. And looking at that, that is a secondary feather. It's not quite as curved as a primary feather. This is a primary feather, which is very asymmetric and also curved. So feathers are no different in the fossil record than the feathers that we have today on birds. So feathers haven't changed in any way. Feathers have remained the same. So the argument I'm using here is that even using the evolutionists' own framework, which I don't accept, you can actually show that there's many examples of what the technical term is stasis. That is, that essentially you haven't got any change. Now, there's many other examples we could look at. Briefly, let me look at some other flying examples. Here we have the fossil of a moth. You can see it's a moth because of the tiny little appendages right on the end of the antennae. And that moth is immediately recognizable as a moth. What's more, the wings of moths and, of course, butterflies are extremely delicate. When you touch the wing, if you were to, sometimes you see a butterfly maybe struggling on the ground, maybe it's run out of nectar, perhaps it's towards the end of the summer, and you pick it up, you know that if you were to touch those wings, it would be so delicate that, you know, it would destroy the wing. So we know that to get that impression in the rock, it's telling you something else. Not only is it telling you that butterflies haven't changed much over supposedly this time 50 million years, it's telling you another point. And you can probably think it through, can't you? Because you don't need a lot of training in evolutionary geology to actually consider this point, or any view of geology. You really just need common sense. Because in order to get that impression, it's telling you it must have been buried quickly. It must have been buried fast to get that impression in the rocks. So rock is essentially, when we're dealing with sedimentary rock, that is waterborne rock, it is essentially hardened mud in this case. Not all rock is the same, but clearly when you're dealing with trapped creatures, in this case, it's a lot of mud and sediment which has buried it quickly. We could actually move on and look at other creatures, and this is one that I particularly like, because this is the damselfly. The damselfly is a creature which is a four-winged creature. It's lost one of the wings, but you can clearly see that it's a damselfly. That damselfly is the same as essentially damselflies we have today. You don't see half-formed damselflies. The reason it's lost a wing in this case is simply because it's been I would suggest, in a catastrophic event which has buried it. And therefore, in that violence, one of the wings has been removed. But the main issue here is that damselflies have remained the same. When we look at dragonflies, the same issue applies. I've got here a picture of a fossilized dragonfly. The only difference might be, again, in size, that some have been found with a wingspan of 3 feet. No evidence of change. So this now raises yet another issue, because not only have you got examples here of creatures which are really essentially the same as in the past as today, you've also got evidence that these creatures must have been buried quickly, because you can actually see the veins on the wings. But there's yet another point. In this particular class of creature, we're looking at what we call metamorphosis in these particular creatures. So you don't see evidence of half-formed worm-like creatures changing into those which will become caterpillars and then become butterflies or moths. Or, in this case, not caterpillars, because you know where these creatures start. Perhaps some of you don't. But dragonflies don't start on land. They start where? In the water. So this raises yet another issue. How on earth is there the supposed evidence of change over millions of years of this type of creature, when in order to get it started, you would have to have two body plans emerging from a creature supposedly before as an evolutionary precursor, which only had one body plan. And the amazing thing, of course, is with dragonflies and with damselflies, but the same point applies to all creatures which have two body plans, like butterflies and moths coming from caterpillars, that the second creature is the one that lays the eggs. It's not the first creature. So in order for supposedly an evolutionary scenario to work, you've suddenly got to have two body plans for that creature to be promoted. So there is no way that you could get a slow evolutionary development of metamorphosis. Now, there are many other examples. We could think of examples in the plant world. Here's one when I was flying through an airport, I think it was Albany in upstate New York, that I saw this wonderful display of fossils, and I immediately took a picture of this one, because this is in the later Carboniferous rock, and you can clearly see the impression of that which looks identical to a fern that we have today. I've got another one here, which is a much smaller example of a fossil fern from British Columbia. This is a valuable fossil, but I will risk passing it round. Could somebody like to take it, please? I'd like you to look at these fossils. And you can look at some more which I've brought with me. So this is rather like the picture on there. It's a fossilized fern. And again, it's showing you, A, that the fern is like one we have today, and B, that there is no way that fern could have been formed slowly in the rock. Because what happens when you, lads, when you get a bunch of flowers for your missus or maybe your girlfriend, what happens after a few days? Even the best of flowers, they wither. In case you didn't know, you put them in water, you perhaps just spray out the stalks and stop the air getting in, which, by the way, is how to keep flowers lasting longer. I don't know whether you knew that trick, but if you exclude the air, that means that the water will come up and then they last a bit longer. But even after a week, maybe 10 days, you've lost it, okay? So there's no way you can get those fern impressions unless it was snapped or in lots of rushing water and mud, and as it were, the snapshot was taken fast in order to get that impression. So the plant world, and remember now I'm going down the geological column, so we're talking about something of the order, sorry, I've gone backwards. We're talking about something of the order of, in the region of supposedly 200 to 300 million years ago. And the fern is just identical to a modern one. I love this next one, which is an octopus. It's not particularly a creature that I would enjoy meeting in the water. I've seen some in a water zoo, whatever you call it. In Brighton, they had a marine life exhibition. But they are an amazing creatures. Stuart was talking, or Professor Regis was talking about the eye of an octopus and just how amazingly designed it is. But also you probably can if you look closely at this picture, you can't see it from where you are, but you can actually even see the ink sac in this fossil. You can also see even the suckers on the 8 arms. Now, this is an amazing fossil because there's only one little bone that an octopus has, and it's near its mouth. All the rest is basically cartilage and soft tissue. So how on earth did that get fossilized? There's only one answer. It was buried alive. I'm sorry to say this, but that's the gory detail. It was squashed alive. And that's how these impressions have been made. There are even fossilized jellyfish, which you well know, jellyfish just disintegrate when they're washed up onto the sand. Sometimes you see them. And I love this one because this is from your own city. And you have a capacity in Scotland, and I love the Scottish people because obviously my name comes from here and I'm wearing a Scottish tie, so I'm not declaring war on you when I quote the Edinburgh Museum, but this is what it says. This is a king crab exhibit here in this city. And here's a modern king crab, sometimes called a horseshoe crab. And here is a Jurassic horseshoe crab. You know what it says on the exhibit? At least it used to say this. You can't read that, so I've blown it up. Although some 150 million years separates it from its Jurassic ancestor, shown in this case, it is strikingly similar to that ancient form. That's a typical understatement. It's exactly the same. There is no difference. So the point holds true for all these creatures, that horseshoe crabs and all these other creatures have remained the same. So now I'm going to change the argument, as I said I would, and move now to other creatures. Let me just summarize where we've got to. Basically, I've said that all those creatures, and I've not done them all, but I've put up a lot more examples there. We could have talked about the coelacanth, we could have talked about the lacewing moth and a few others there, but they all show evidence that they are really no different to modern examples. So, of course, the evolutionists will immediately say, but you've cherry-picked the data. What about those creatures which are now extinct, such as dinosaurs would be an obvious example, and not so well known, trilobites. These are creatures, the trilobites, which supposedly existed way down at the bottom of the part of the column that I was showing you. Actually, the column keeps on going down to the Archean and Hadean rocks, which are underneath the Precambrian. So it's not that it ends at the Precambrian, but the trilobites are in the bottom bit of that which I showed you. So the evolutionists will say, but it's the other creatures which were changing. So let's look at this point. Trilobites and dinosaurs, where do they sit in the geological column? Well, the trilobites sit down here and the dinosaurs sit up there. Well, everybody likes considering dinosaurs, so we will come to those. But let me just briefly consider trilobites. Now, if you're not familiar with what a trilobite is, I've got some of our friends with me. Now, you need to remember that according to evolution, this is your great-great-great-great-great-great-great-great-great-great uncle. Or I may have got it wrong and it was a great-great-great-great-great and so on aunt. But you need to treat them with special care. So these trilobites are actually quite valuable. This one is quite valuable because you can actually see the eyes, which I'm going to talk about. But I'll pass these on this way, if I may. And I'd like you to just pass these round. That's a little bit damaged on its eyes, but I want you to notice that Fred was lying over his mate Martin and they got buried together. And I wanted you to see that. So that was the end of them. I've also got some other fossils here, and please take care of this one because this is an ammonite, right? And it's both sides of the ammonite, and somebody gave this to me, and this came from Whitby. Right? And there's a lot of fossils that you can find on the Jurassic coastline in northeast England. You've also got it, so it's not far from here, just, well, It is a bit far from here, but you've got to go about 150 miles, I guess, from here, south. But you also got examples of Jurassic rock exposed near Lyme, Regis, and other places on the south coast, as you well know, some of you. So can I just pass this round to you, sir? And please have a look at it carefully, but please don't drop it. We haven't had major accidents on these, but I could be the first one to have it. And there's more examples of trilobites here, so I'll pass that one round to here as well. So pass this trilobite again. So you've got an example of a trilobite. And there's a good fish fossil here, which I'd like to pass around as well. That's an example of a buried fish. So now, the question is about trilobites. Were trilobites gradually evolving, even though we don't have modern trilobites to compare them to? Well, this is the issue. Trilobites had amazing eyes. The eyes were compound eyes, because we can see them on the examples of the fossils. Some of them you can actually see the eyes were compound eyes. But get this, the individual lenses were not made of protein. As far as we know, there's no other example of a compound eye in any creature that ever existed or exists today which has an eye which is not made of protein, but is made, get this, of mineral. It's an actual mineral lens. It's not glass. It's actually made of calcium carbonate, or sometimes called calcite. Now, calcite is found in the rocks, and in fact you'll find an awful lot of calcium carbonate in all sorts of different formations. Sometimes you get pure crystals of calcite like this, and that's what you get normally. But now I'm going to tell you something more about calcite. Remember, this is in supposedly thereabouts 400 million year old rocks. Some of them are found in layers slightly above, so they would be traditionally classified as somewhere in the region of 300 million. So it'd be Ordovician and sometimes even found in the Devonian. And when you look closely, those eyes, those individual lenses are made of calcium carbonate. Now, with my thanks to Mark Surtees, who's in the audience somewhere, he once gave me a lump of calcite, which is the same one that I'm showing you here, and he very thoughtfully put a card behind it with a line on it. And he used to run a shop. Not sure that you run it anymore, Mark. Are you here somewhere? He's just gone out. But, oh, there he is. But this lump of calcite actually shows two lines. So Mark's just come back. He used to run this shop, didn't you, Mark? No longer running it now. But that lump of calcite is showing two lines. Now, why is that? It's because it has a very special property. And that property is not really going to be of much advantage to the trilobite. But it produces two images like that. If I pass this calcite round, this is, if you could just pass this round with the little line underneath, you can see what I'm talking about. Now, why is it producing two images? Well, it's because what happens is that there is two parts to light. There's light in one polarized part and another polarization, which both of them are at right angles to each other. Light behaves in this way. It has two parts to it. In fact, this was found by a wonderful scientist, whom of course you should know up here, called James Clerk Maxwell. He actually showed the electromagnetic radiation and showed that it was actually waves in two fields at right angles to each other. And when you actually look at this, it gets a bit complicated to actually indicate this, the two parts of the light are actually being bent at two different angles when they are incident on this material. We call it birefringence. Now that's the complicated bit. But actually you can turn that lump of calcite and get the two images to come together, at least holding the angle of view the same. However, when you change your angle of view, you've still got to turn it to get it right. And it's actually very difficult to find the line of sight such that those two images could come together. But there is one angle or one line of sight defined by the rotation angle and the angle of movement above the calcite where those two images will come together. We'll call that, for the sake of argument, the special axis, right? Now let me come back to that picture of the trilobite eye. Each one of these little lenses has a center line. You understand that? So there's a line which goes down the middle of the lens. That center line, you wouldn't believe this, is lined up exactly along that special axis. So that means that trilobites were not seeing double. Every single lens is as though an optician or a careful craftsman had cut out the calcite, made a lens, making sure that the line of sight, which goes down the middle of the lens, is lined up to that special axis that I just referred to. Wow, that is just astonishing. And this creature was meant to be primitive. You see the point that I'm making now, that even with creatures that we don't have today, there is no evidence of them having gradually formed. Let me play you a little film which will just summarize this point. Just turn up the volume a bit, may I suggest?
If evolution were true, the fossil record should show one type of animal life in the lowest layers, then two, then four, and so on. But Darwin himself had a difficult time explaining what we now call the Cambrian explosion of life. Cambrian rock layers contain nearly all the basic animal forms, including echinoderms, arthropods, and even chordates, with no trace of transitional fossils in lower Precambrian rocks. And each fossil exhibits amazing complexity. For example, Cambrian arthropods had advanced compound eyes, like we see today in dragonflies and bees. The eyes were tuned to the way light travels through water, allowing the creature to see straight. This required each eye to have over 3,000 interconnected lenses. Compare that to only one lens in each human eye. Cambrian rocks also contain fossil fish that look like today's lanceolids and hagfish. The fish had perfectly crafted skeletal supports inside their bodies, an opposite arrangement from Cambrian arthropods like trilobites. The Cambrian layers show an amazing amount of diversity and complexity. Evolutionists claim it happened in a mere 5 to 10 million years, the equivalent to a blink of an eye in so-called geologic time. Sudden appearance? Instant complexity? That doesn't sound much like evolution. Instead, the fossil record shows fully formed creature groups right from the start.
So that really summarizes the point that I've just been making. And by the way, you can get more of those on the Institute of Creation Research website. The first one came from the Answers in Genesis website, which I forget now what they're called. Check this out, that's right, it has a different name. The ICR ones are called That's a Fact, which we've just shown you one. Now let's just briefly look at dinosaurs. Dinosaurs, of course, may not necessarily have looked that fierce. That, of course, is just an artist's impression. But now we're moving the argument on. We're again dealing with creatures we don't have today. So the argument is, well, were these creatures gradually changing into something else? Well, you know what the evolutionist says, and he seriously proposes it, that birds have evolved from those creatures. I don't agree with it at all, but that is what they propose. They will say that Tyrannosaurus rex, or not necessarily T-Rex itself, but creatures like that, tetrapods, actually some of them were gradually changing into birds. Now, is this really the case when we examine what actually is the evidence of the fossils and the rocks concerning dinosaurs. There are a number of examples of cases where dinosaurs are buried in large numbers. They're called dinosaur graveyards. This particular example is found in Spain, where 8 different dinosaur species, including several kinds of armor-clad plant-eating dinosaurs, were buried in a site which also, at the end of the article, it says, included turtles and crocodiles. Now, I ask the question, what were these land creatures, because they're land-based dinosaurs, what were they doing milling about with turtles and crocodiles, which generally are in the water? They're amphibious, of course, but they spend a lot of their time in the water. That would strongly suggest that there is something odd going on. Then also we need to ask the question, how come 8,000 were all buried together? That's quite a lot of creatures. By the way, this is very rare. It's very rare to find any creatures other than fish, which are the most that we find in the fossil record. And it gets harder and harder to find fossils the further up that geological column you go. But there are some examples, and this strongly suggests catastrophic origin to me. So we both agree on both sides of the fence of this issue that these creatures have become extinct. So the question is not that we no longer have them, we accept that, but that we notice that not only were there a lot buried all together, which immediately suggests catastrophe, but also buried with them were creatures that we do have today. And the creatures that were buried with this particular example were crocodiles. Well, what do we know about crocodiles? Well, again, it's not a creature I particularly want to get that close to. But those creatures, we have them today, and they are found in the fossil record. And guess what? They look exactly like the crocodiles we have today, except some of them were gigantic, which would be the length of this room. Looking at this, the head of this particular one, which was found underneath the Sahara Desert. Absolutely huge crocodiles, but recognizable as crocodiles. So what's the argument that I'm now using? The argument is this, that crocodiles, yes, we have today, and the fossils of them are essentially the same. So what the argument is this, that if dinosaurs are found in exactly the same rock and sometimes next door to them, as in the case I've just mentioned, that's really becoming a very weak argument on the part of the evolutionist, would you not accept? Because he is now relying on creatures which he has no evidence for that they've really changed into something else. And he is simply really arguing from silence that he's got other creatures which certainly haven't changed in the same rock, and then he's saying that creatures which are next to them have changed markedly. Now, of course, he will say that dinosaurs eventually suddenly became extinct. They do talk about sudden extinction events, talk about meteorites hitting the Earth 65 million years ago. But actually, everything is consistent with what the Bible says, that there was a worldwide flood, and that all the creatures outside the ark were buried. Do you now see that this is now strongly suggesting that the biblical position has a lot of evidence which is consistent with it? Now I'm going to come in this last part of the talk to consider radioactive dating. Because people will say, but surely the rocks show that everything is millions of years old. Don't we have certainty that those rocks are millions of years in ages? Let me turn to something which is in my own area. Although I'm not a professional geologist, for a long while I was studying coal and the ignition of coal, and the fact that it would slowly burn away. and there's a lot of problems with what's called thermal runaway. Some places have an enormous amount of coal, like Australia, where the coal fields become off the coast of Melbourne and the south, in Victoria. Off the coast, the coal fields become a depth of 3 miles thick. Now, we don't have coal to that extent or to that thickness in England, but we do have coal. You have coal in Scotland. You have coal over Europe. Lots of it. There's coal, of course, in Asia, other parts of Asia, Kalimantan, Borneo, and Indonesia, Malaysia, coal in New Zealand, coal in Antarctica, massive amount of coal in America, in the US, and of course up in Alberta in Canada. So right across the world we have coal. Now, why is coal important? Coal is essentially buried plant material. When you leave vegetation out at the bottom of the garden, and the Americans say the bottom of your yard, and I love playing around with that when I'm speaking to the Americans, because they don't understand garden. They don't know what a garden is, so I have to use the word yard. A yard to me is all paved over. But so when you put a lot of vegetation at the bottom of the garden, it just rots, and it doesn't produce coal. The most you could possibly produce on the surface might be something like peat. That, of course, a lot of it is found in Ireland and other places. It's well known for its peat, but you won't get high carbon content coal. You won't get anthracite and other very high carbon content coals. You wouldn't even get brown coal, which is a lower carbon content coal. You wouldn't even get that. And that's found all over the world. The only way you can get it is by burying it quickly. So everything in the rocks themselves is telling you, particularly with coal, that there is rapid burial. But what about, though, the radioactive dating issues? Well, radioactive dating works like this. You've got to know that you've got a clock of some kind, and if you're going to have a clock, you've got to know what the conditions were at the beginning. So I'm using here the illustration of a sand timer. I've got a better illustration here, so I'll move to that slide, where you've got, this is an illustration only of the idea of something acting like a clock. The real issue is you've got one isotope of a chemical changing into a different isotope. So it might be potassium 40 changing to argon 40. Now, that's all to do with the construction of the number of protons, and it's to do with the nuclear chemistry, which changes over time, and the parent changes to daughter. But of course, if you saw that at the beginning, like that, you'd say, well, you're not starting with everything in the top. But you don't know what it was in the beginning. You don't know whether all the sand, in my earlier example, was all in the top or the bottom. And that's the same issue with radioactive dating. You don't know how much was there of the parent element and the daughter element to begin with. Now, to be fair to the evolutionist, he will try to get round this by developing other schemes called the Isochron Scheme, which I won't go into detail of here. But he has ways by which he is trying to work out what was there in the beginning. But he actually doesn't know. And that is the basic issue. There is still calibration issues, even with these other methods that he attempts. So you don't know what the original ratios were. You don't actually know whether something wasn't added or removed in the process. Remember, this is an illustration. It's not really a sand clock, but the sand clock is something we can get our minds around, so you can actually see the similarity in the, use it as a way of understanding radioactive dating. And the big thing that you don't know is the rate of decay. Now, even supposing that the rate of decay were the same, you still have the main issue, which is you don't know how much of the parent and daughter element were there to begin with. So there are big issues with radioactive dating. And now comes the rub. There are some elements which decay very, very fast indeed. Much faster than potassium going to argon. Much faster than uranium going to lead. Much faster than rubidium going to strontium, where the time taken to come to half the original value is, and we call that the half-life, that time is of the order of millions of years, right? But there is one particular case where carbon-14, you've heard of carbon-14, decays so fast that it only takes 5,730 years for it to come to half its original value. Now just think with me for a moment what this means. After roughly 11,000 years, it's come down to a quarter of its value, right? You with me? You divide by 2 again. After another 5,700 years, it comes to 1/8. You see what I'm doing? I'm dividing by 2 each time. Now, if I go to 10 half-lives, that's 57 odd thousand years, right? You come to 1/2 to the power 10, which is, on a Saturday in Edinburgh in November, what is it? What is 2 to the power 10?
224.
That's right. The computer scientists here know that that is about 1,000, right? So supposing I went to 20 half-lives, what would it be? 1/1,000 times 1/1,000 is a, come on, a millionth. So you'd have basically lost all the carbon-14. So the point is this, that if you find anything with carbon-14 in it, it must be less, not that it's anywhere near a biblical timescale, and I accept that because the biblical timescale is less than 10,000 years, but I'm coming to that. But as I just round off on this point of radioactive dating, please understand the significance of this matter of carbon-14. Carbon-14 decays so quickly that we shouldn't have anything left, and yet we find that there is plenty of examples where carbon-14 is present. Take this example. Here's an ammonite found by some friends, actually, who work over in California. They do some fossil hunting, and this was found. An ammonite, which is supposedly in rock which would measure at about 160 million years old, or sorry, not quite as much as 160, about 120 million years old, with a bit of wood which has got carbon-14 in it, which would date it at less than 100,000 years. So what's the answer? Something is wildly wrong in the estimates that people are making concerning concerning the millions of years. So let me now really drop a bombshell. Did you know that people have found T-Rex with soft tissue in it? Dinosaurs, where the fossilized bone, the femur bone, has been broken open, and in the marrow is soft tissue. Soft tissue that you could have put into a microwave and had a T-Rex steak. You could even see the blood vessels in this soft tissue. This was about 10 years ago that Mary Schweitzer found this. She was astonished. She has tried to justify it since by saying, well, you know, it's amazing, but this must have lasted for millions of years. There's no way that soft tissue could last that long. And what is more, people who are on our side of the fence have done some carbon-14 dating of dinosaur bones and found significant amounts of carbon-14. So when you combine both issues, soft tissue and carbon-14 significant measurements, what's that telling you? That these bones are not 65 million years old. By their own reasoning concerning carbon-14 decay, it has to be less than 100,000 years. You say, well, that's still not biblical timescales. let me lastly deal with that point, because what, of course, is underneath all this is how does carbon-14 form? Carbon-14 forms by cosmic radiation hitting the upper atmosphere, and it produces carbon-14 from nitrogen. Then that's, of course, absorbed in creatures which are breathing air, which take in some of the carbon dioxide which has carbon-14 in it, and that gradually decays back to nitrogen, as I've just been saying. So the cosmic radiation is what causes it. Now get this, the amount of water content in the atmosphere affects the amount of carbon-14 that is formed. I have a book here which talks about a lot of water. Do you think it might just be relevant? Of course it is. As soon as you actually understand that the pool of carbon-14 today may not be the same as in the past, and there's a good argument for saying that before the flood there was possibly some protection against cosmic radiation coming in, then that means that the creatures which were living then had less carbon-14 in the air that they were breathing, which would immediately collapse down the 40,000 year readings that I've showed you down to biblical timescales of 3,000 or 4,000 years. So what do the rocks really say? The rocks are consistent with catastrophe. Did you know there is examples of fish eating another fish? There's an example here of an ichthyosaur giving birth to another baby ichthyosaur, and like a snapshot in time, buried. The argument is catastrophe. Forgive the cartoons, but this just makes the point well. Underwater sediments buries the creature, in this case a fish, and the fossil is formed. What I've been showing you is evidence of catastrophe. And what is the obvious alternative? The biblical flood. What we need is biblical view of the evidence. And that is really the issue. That the evidence is consistent with the biblical worldview. Why don't people want to consider a biblical worldview? Because they know what the implications are. It means that they have to accept that the Bible is true. And people don't want to go to that point. May I say then that really, when we consider the evidence, it agrees with what the Bible says. The world that then was, being overflowed with water, perished. But you know that the Bible goes on to speak in that same passage that the world which was buried in the past is like the world now, which is going to face a fiery judgment to come. The real issue, and there may be some here who have not yet closed with the Lord Jesus Christ, the real issue is, are you safe? And that's why the evolutionist doesn't like to look at the rocks from a biblical point of view. He doesn't like to think that there is a God who commands a judgment against sin, and there is. And the judgment that is coming by fire will not be escaped by entering into an ark. It is only escaped by believing in the Lord Jesus Christ, who died on a cross that we might be forgiven. That is the issue. The rocks speak of judgment, and no man today or woman likes to think that there is a God in heaven who commands history. Thank you. Okay, thanks very much. We're going to have a break now for lunch. So there are plenty of cafes. Maybe you brought your own sandwiches. You're welcome to eat in here, or go and get something to eat downstairs in the cafe or elsewhere. And be back for just before 2 o'clock. Kick off again at 2 o'clock. Thank you.
There's some cake as well for dessert. They've got a piece of cake for everyone here. For dessert, along with your sandwich, coffees and teas served here.
when you finish with the fossils, can you place them back on the table at the front? And can you pass them all around so that people can see them? Oh, yes, Susan Wilson. Yes, of course you are, Susan, yes. Lovely to see you, Susan. Sorry, it's a while since I've seen you, so that's why I didn't immediately...